So inequalities are not that different from equalities, but what we're going to get is a load of options, really. So inequalities can be used on a number line, and we can represent with an open circle to show that something is greater than or less than. It doesn't actually include the number itself. So the big open circle says that whatever we're looking for, in this case we'll call it x, is greater on the x-axis, is greater than 1. So it can be literally any number greater than 1. And if x is less than 1, it doesn't include the 1, so it's anything less than 1, including not whole numbers. A closed circle will include that number. So x is greater than or equal to 1. You'll see here that it is a solid, same thing, solid circle. If x is going to be any number, as long as it's less than, and including 1. So x could be 1 in this case. A set of numbers, you can have a sort of a set of numbers in between where it is, this number x is going to be greater than -2. Isn't it weird how I said that? Because I could say, if I went in order, -2 is less than x, which is less than or equal to solid circle 3. So x can be anywhere in that range of numbers. It could be -1, 0, 1, or 2, or any of the numbers infinitely in between them, such as fractions, decimals. Linear inequalities can be solved in a similar way. They're very much like linear equations. So instead of an equal sign, we will have one of those other signs. But we have to be careful. Only really when we multiply or divide both sides by a negative number, then we swap the symbol. Let me show you. So if 5 is less than 8, true. But -5 on a number line is actually going to be a bigger number than -8. So we divided both sides by -1. So that less than became a greater than, and that makes that true. So if -x is greater than 1, divide both sides by -1, we get positive x will be less than 1. If we swap sides of an inequality, so if we just decide that we would rather see 3 come first instead of 7, well, 3 is less than 7, and 7 is greater than 3. So 3 is still less than 7, but we need to make sure that that's reflected in the sign. So if 2 is greater than whatever x is, x will be less than whatever 2 is. So let's look at it here on the line. So show each of the following. X is less than 6. So what kind of circle is that going to be? That is going to be an open circle at 6, and less than is going to go this way forever. So this gives us x is less than -6. So if x is greater than or equal to 2, above the 2, because it can be 2, greater than or equal to 2, we put that and we put a sign, an arrow going that way that says x is greater than or possibly could be 2. And now we have that range again. So we have -2 not equal to, so that's going to be a circle, so it can't be -2. And -2 is going to be less than x, but haha, x could be, it's going to be less than, but it could be equal to. They should be kind of parallel, shouldn't they? They can be equal to 3, so x is going to be in this range, and that's all it can be. It can't be -2, it's going to be greater. See, and x is on that side of the -2, and it's pointing to the greater side. So x is greater than -2, but less than or equal to 3. Now, when we go to solve these puppies, we can solve them as if there's an equal sign there, just being careful about those negatives. So if we have x minus 3 is less than 7, we got to figure out what x is. So if we're subtracting 3, we add 3 to both sides, we get x is less than 10. And sure enough, if I choose any number x less than 10, like 9, and I substitute it for x, 9 minus 3 is going to be less than 7. Any number that's less than 10. Okay? So for this one over here, 5 minus 2x is greater than 3. So what are we going to do first? We could do a couple of things, but that's a positive 5. So we'll subtract 5, and that leaves us with that negative sign stays there. Negative 2x is less than, let's take us backwards past 0 to -2. How do I get to x? This is where the trick comes in. I'm going to divide by -2, and that will give me positive x. And if I divide -2 by -2, I get a 1. But which way does that sign go? Because I've divided by a negative, the sign that was greater than facing this way is now less than. So this one here, d over 4, so just like our algebra rules would tell us, d over 4, and then 3 is subtracted from it. So we can't just multiply by 4 and go away laughing. So if we're minusing 3, subtracting 3, we're going to add 3, a positive 3. So that gives us whatever d over 4 is will still be greater than or equal to negative 8. Okay, and then the next step is to multiply by 4, because we have a 4 on the bottom, and we want to multiply by 4 on the top. That gives us just a plain old d, so that cancels out. That is a positive number, so I don't need to mess with that. And negative and a positive is that, negative 32. So there were no negative divides. Even though I ended up with a negative number, I didn't do a multiplication or a division with that. So I didn't have to flip my sign around. 2a plus 7 is less than or equal to 6a plus 3. What a fun time. So essentially what we have to do is we have to do a little bit of spinning around. I've got 2a's on this side and I've got 6a's on that side. So why don't I'll skip the step of writing it down. I'll just subtract 2a's from both sides, and that leaves me with 4a's. And then I'll subtract 3 from both sides, and that gives us 4. And divide both sides by 4, and that is going to give us that. And that's fine. That's cool. We like to see it written with the pronumeral on the left. It makes everybody happy. So I'm going to flip it around. But remember, if I do this, and I'm not dividing by a negative or anything, this is facing towards the a, saying that's bigger. So we want to make sure that we've swapped that around as well, so it still rings true when we have flipped it.